Okay, so in 9.2 we hit our first names for some of these series, and these names are important because if you can recognize a specific series and fit it into one of these names, then it kind of instantly tells you what happens, whether it converges or diverges. And the very first important one is geometric. It looks like this: sum of n equals 0 to infinity of a r to the n, and summed out it looks like that with all the pieces. And we showed you at the last class, March 12th, that you can show that this will sum to the a, the coefficient, over 1 minus that r, under the condition that r is less than 1. That means because the terms will get smaller and smaller. If the r is greater than or equal to 1, it will just add bigger and bigger numbers and diverge. We did show you this in class. Second one is called telescoping, and it's basically a sum of two fractions subtracted, and there's no memorized formula for each one. They must be worked out individually, and you must write out and cancel terms to find the sum of one of these. Okay, number 3, the third important thing in 9.2 was called the nth term test for divergence. And page 603 at the bottom, if you're given a sum of one of these, an infinite series, then if you take the limit of those terms as the n approaches infinity, and you can show that that limit is not 0, then the sum of those terms must diverge, because you are adding non-zero numbers to infinity. Adding non-zero numbers makes the sum bigger, 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 and diverges. So we have homework examples, page 605, number 13. They give you a sum of n equals 1 to infinity of n over n plus 1. We're going to find the limit as n approaches infinity, n over n plus 1. Put it in infinity, you get a L'Hopital condition. So limit as n goes to infinity, doing the derivative top and bottom, you get 1 over 1 is 1. That is not equal to 0, so it diverges by the name of the test, the nth term test for divergence. We are pretty much at our 3-minute limit, but squeeze one more in. Page 605, verify that this converges. If you take a sum of n equals 0.9 to the n, this is geometric. The coefficient is 1, which is why we haven't written it. But the r is 0.9, that's less than 1, therefore it converges. The book may call this a geometric series test. Part 1 over, we'll start up with part 2.